Are you able to hear me, friends?
Yes.
Yeah, fine. You might have noticed that this eclipse, though I initiated some time back, all the services of your cluster, they are getting started. That is the reason why it got delayed. I think you might have noticed that. Watch everything what I'm trying to do here, friends. Perfect, friends. Yeah. So I opened my Eclipse and I imported my existing project. So in your case, what you need to do is you need to create a new project. Create a new project. How you're going to do that? New Java project. You give some name, maybe my MR jobs. You give a project name, something like that. My MapReduce jobs. If it is fine to preserve this project as part of the default workspace, that is fine. You want to keep it in a different location, then say I don't preserve in the default location usually. What I do is I've already created my own. I think you noticed here for every component. So inside MapRed, I think you noticed here. Is that clear? I create my project in this location. That is what I regularly do. So create a project there and you can start adding job by job to the existing project so that we will be able to use the same jar file to run multiple jobs. See, there are multiple options here. One, create a Java project you can have in your Eclipse, you can create a Java project and as part of this Java project you can keep only one MapReduce job. So for every MapReduce job you keep on creating one Java projects, then it is going to be a tough thing for you to maintain. That is the reason why under the same Java project I can have multiple MR jobs. So during execution, I'm going to specify the job which I want to run. So how I am achieving that one? I am achieving that one with the help of I am implementing a driver class to this project. In this driver class, please don't get confused with the driver code and the driver class. Driver code and the driver class. Inside every MapReduce job, we will be having, this is your job class, and inside that we have a mapper class, and we have a reducer class, and we have a main method. Inside the main method, we are going to write the driver code. This is where we write the driver code. This driver code is only to this MapReduce job. But I am saying driver class. This driver class is to the entire jar file. I mean, Whenever you specify any jar file, you want to run a jar file, we need to specify the entry point for the execution. Entry point for execution. So for that sake, what I do is, when I need to specify an entry point to this entry point for the execution to this jar file, I specify this driver class. So whenever I'm saying here on the terminal, Hadoop jar, I specify my jar file, say yes, Hadoop jar work slash mapred slash mrjobs.jar. Here, whatever the job I want to run, if I want to run this one, then I specify this name. I hope you are following with me what I am sharing here, friends. So what I do is simple word count and slash tmp slash sandbox slash Mary slash tmp slash sandbox slash Mary underscore out. If I give like this, what is that? Simple SIMPLE, simple word count. Oh, is simple word count not there? No, no issue. No issue. Let me regenerate the I right click on my project. I say export jar file. Choose the path where I want to keep my jar file. That is inside my MapRed. Same I am keeping here. Next, next. Here I am going to specify what is the main class. The main class I specify is going to be, because inside every MapReduce job there will be a main method. So every class is going to be a main class. But what is the class that I am choosing here? The main class, the driver class. That is going to be the entry point for the execution of my entire jar file. I click on finish now. Yes, I say yes. Now been done. Now look at this. When I am giving this name called simple word count, simple word count, simple word count, tell me what is the job that is going to be executed, friends? When I am giving the name called simple word count, this is a name I am giving. So this is a class that is going to work in the background. What is this class? Simple word count class. And here you see, this is the word count job that is going to be executed. There is a static inner class, that is the mapper. Static in a class, that is a reducer, there is a main method, and there is a driver code. You noticed here what I am trying to share with you, friends? You see, map 0%, reduce 0%, map 100%, reduce 0%, map 100%, reduce 50%, map 100%, reduce also 100%. Then the job is considered to be executed, and you can see the output in your Mary underscore out. You can go there and see Hadoop PFS hyphen slash sandbox slash Mary underscore out slash part hyphen R hyphen. You will be able to see the output clearly. Why? No issue. Oh, So you can see that here connecting to the resource manager, the file input format, total input paths to process is 1 because you have only one file that is being processed, that is a Mary file. Number of splits 1. I think you see that very clearly. The job has got the ID. The job is running. You see that one here, map 0%, reduce 0%. Then your map going to 100%. Reduce is not yet started. You see that closely. Weblog comment word count. Okay. No, this is also not running as expected. Weblog comment word count. Why this is coming into picture?
In the simple word count uh, Java file, we are using the word count mapper. I mean, that is the reason it's calling the word count mapper.
Now come out again.
Yeah, in the driver code, so we have a mapper class is the word count mapper class.
This one only.
Yeah. So this it
I'm
might
using the
be.
same.
Yeah, this is reference to that word count Java, word count.java code.
No, that is SO. Um,
Okay.
you see here, this is SO word
Uh,
count mapper
okay.
and int sum reducer. And here also you see SO word count mapper and int sum reducer. So for sure, this is also not going to give the outcome because for MapReduce tasks, we have set only in this, we have set the number of reduced tasks to be 4 in this word count. Let me figure it out. Driver.add class, simple word count. This is perfect. Let me com dot, 1 second, sa dot com dot sa dot mapred dot simple word count dot class. Okay, this is for my simple word count. Clear? Inside the simple word count, we have word count mapper which extends this one. So what is that I kept here? Set jar by class is simple word count only. Set mapper class is word count mapper. Number of reduced tasks, I made it 1. So this is fine. So we are not setting that anywhere. Extends configured. That is perfect. So work mapper mr jobs.zar. Let us go and delete that.
Delete the jar file
Exactly.
and rebuild it.
Work MapRed. I delete this. So mrjobs.zar is no more in existence. Export the zar file. Home cloud work MapRed mrjobs.zar. Okay, that's fine. Browse. I give the driver name and I click on something called finish. We come to know the name of the job that is getting executed. Interesting. Why this weblog? I'm killing that because I understood that this is not the right job that I am interested to run. So I killed that. You noticed? I killed that. Simple word count. I'm running the word count only now. That is a problem. Okay, it has created in the before execution. It has created that Mary underscore out directory has been created. That is the reason why it is throwing an exception saying Mary underscore out already exists. I told you very clearly the output path must not exist and input path must exist. So taking that into consideration, this time it is a blog comment word count is getting executed. I'm giving a simple word count. Why it is throwing? Which other place we are specifying simple word count, and then oh my god. Fine, let this run, let this run. So these are the practical things that we need to face to come out with the proper aspects. Okay, let this run. So this is, anyone able to notice, friends? Look at the code. Anyone able to notice what could be the issue? Prasad, Ram,
The job class, job is equal to new get config.
very good, very good, very good. Here we need to make this as a
Yeah,
simple word count.
yeah, yeah.
So the same thing we do now, we thrash this one and now we try to run the same thing. In the place of word count, now I'll be running my simple word count, and this time you will be noticing in the Hue browser when the job has been accepted. Oh, sorry. After making the change here, we need to regenerate the jar file
Rebuild the jar
port,
file. Yes.
and we are specifying that yes, main class is my driver class, and I click on something called finish. Override this one, yes, perfect. Now let us go to the Hue browser and look at you got it now? You noticed here simple word count. You noticed here simple word count is what is running now, and you need to see the output because I clearly specified in this the number of reduced tasks which I want to run. One. I kept it explicitly one. There should be only one reduced task that should run in the background. So you know very well each reduced task will produce one part-tar file. If there is only one reduced task that is running in the background, you'll have only one part-tar file. So now I can comfortably view that one, whatever I was trying before. Yes. And you should definitely see the outcome. Hope you got the output here. What is that? Mary two times, capital M, and everywhere two times, follow two times, and then you have little four times, Mary 11 times. So you could see very clearly here how things. So let us revive everything now. What we did here.
Srinivas,
Yes.
question. Reduce task. You mentioned one right here.
Yes.
For the word count job, you have mentioned four. So pattern files for pattern files being generator. So what is the output for the each pattern file? It's going to be same or it's going to be different?
No, 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 no. See, if you look into the diagram, what I've shown you in the last discussion, let me open that for you. Maybe something like the outputs from all the mappers running on multiple nodes. If you set the number of reduced tasks to be only one, the entire outputs of all the, of course, combiners also there. So the entire output of all the combiners and in the later stage partitioners, all that output is routed to one reducer only. Okay. Suppose if I set the number of reducers to be 4, the entire output from the intermediate stage is uniformly distributed into 4 parts, and that is been sent to 4 reducers. I will try to run that file also. Have a look at this one. In the place of this, let me finish. Let me delete this one and run this once again. In the place of this simple word count, I'll make it as a word count. So when I make it as a word count, what is the job that is going to be initiated? This is a word count. And for that sake, this is a class. What is a class? This is a class. Now in this class, set jar by class is that one. Mapper is SO word count mapper. Reducer is in some reducer, which belongs to the same. Number of reduced tasks, I made it to be 4. So if you go and see the part-R files generated in the background, 4 part-R files we get. And their sizes also will be somewhat nearer. Maybe the size is going to be different, but the number of key value pairs inside each part-R file will be very close. Say the entire output from all the mappers, assume 100 key value pairs been produced. Each reducer will get 25 key value pairs roughly for next level of processing. I think you are getting my point. I think is this Prasad raised this question?
Yes, Srinivas. Yeah, I'm getting. Yeah, I got you now.
So I'll show you now the part-R file that is being generated. I mean, multiple part-R files been generated in the background. Then we'll be seeing. I'll take you over there. Now it is. You notice that what is the job that is running? The job that is running is your weblog comment word count. Okay. This is not a simple word count. So when I take you to this /tmp /sandbox /Mary_out, what is the logic that has been missing there? No issue for that. MRDP utils or transform XML to map and escape this one. That is okay. And this one. One second, friends. Because the theme of this word count is different than your regular word count. there is a there should be a file by name weblog, that is an XML file basically. No issue for that. We'll download that weblog XML file. Weblog XML file download. We need a web server log in the XML form. That's the reason why we are searching for this. Sample weblog in XML format. But this is not the. I need to have that file with me, but I don't know what is the name that is being given to that. Cat user iPhone logs.txt. No, this is not. Users dot. No, this is not. So I need to have that file. Back. Oh, cat Apache. No, not this one. JSON format. Mary. Microsoft Web Data. Microsoft Web Data. No, not this one. I don't know where I kept that file. No. So this implementation is actually done based on that file only. So comments.xml, no. Doc3 employees, English, names. If not, I'll find out that file, friends, so that we'll be able to work with that one. So we need an XML file. I don't know whether you're whether you've gone through this statement here or not. MRDP utils.transform XML to map. You notice that one here, Prasad, Ram?
Yeah, I noticed. Yeah, so it's like a you have XML file that
Yeah,
transforms
yeah,
to the map.
exactly. So I'm converting my XML file into a map, and I'm trying to get only the tag called text. You see here, parse dot get of text. Only that I'm trying to get. I'm not interested in converting every word. I am only interested to get the data from the tag called text. So that only I am converting. If that is null, I need not process anything because that doesn't have any text. And if that is having text, I am converting that into lowercase, replacing all the unwanted, and finally converting into my tokens. So this logic is as is like your word count only. But what is this part? What is this pre-processing part? What is this pre-processing part?
XML parser
So what we are trying to
logic.
do is, we are trying to convert the XML weblog file into XML weblog file. What we have is the input to my job. So what this job is doing, converting each record into a map instance. From map instance, I am getting, what is the element I am getting? Text element, nothing but the tag. If it has a text, then we are transforming that text into plain simple text without any special chars and digits. You notice that here what the logic been written. If you have any apostrophe, something like that, I am replacing with nothing. Replace all. Other than small a to small z and capital A to capital Z, everything I am replacing with empty. Hope you are following with me what I am sharing. Once this entire pre-processing is done, what I am trying to do is I am converting that string into the text into tokens, and each token I am reading context.write of word, whatever the token that we got, and I am keeping one. That one is nothing but your int writable, whose internal value is numerical value 1. So this code is exactly same like word count, and the reducer is same like your regular word count program only. But what additional, see, the intention of showing you this implementation is to make you to understand word counting is not only to your plain normal text files. Word counting can be applied to any other, provided we are going to parse that content into the text format before we perform the word counting. Let it be XML file, Word document, PDF, anything. Your word counting is definitely possible, provided we do the pre-processing on the text, so that we will be able to parse that one and get the simple text. That is out of the whatever XML or PDF, because when you are working with your Word documents, PDFs and all, we cannot expect, of course, when you are seeing through your Acrobat reader or seeing through your Microsoft Word, we will only see the content inside, the text inside. But those files will have lot of metadata inside. I want all that metadata to be parsed before the text is being extracted from those files. Once the text is extracted, I am doing my pre-processing again, converting all my non-required characters into space or empty, and finally converting that into to string and then into tokens and finding the word count again. So remind me probably the next session. I'm not finding, various XML files it is showing, but we need a weblog XML file. So let me get that weblog XML file and run it again. This again is the same word count. Then here, all the 4 partar files, because now the data is not as expected. That is why all 4 partar files generated, they are empty here, not having any data inside. But when you give the appropriate XML file, you understand why we are getting the empty here, friends? Why we are getting empty here?
Yeah, there is no file exists there.
That is one reason. Other reason is parse.get of, we are interested to get the element by name text. That only we are converting into string. So every time we get a text equal to null, from here only it gets returned. This code will not be executed at all. That is the reason why we are getting all the 4 partar files to be empty. So what is expected when I call the method called parse.getText? Now I tell you, suppose if this entire code is being commented. Look at this one. If this entire code is being commented and run against your, what is that here? I say value dot to string. I save this one. See, as we don't have that file, we altered the logic now. As we don't have that file, we altered the logic now. So what I try to do is,
Create a jar file.
oh sorry,
Then change the code.
yeah, sorry, because I habituated working with automated environments, so expectation that once we make the changes and save it, it automatically happens. We'll be under that impression. Okay.
So you mean, I have a question, Srinivas.
Yeah, please.
So you mean in your environment, like you have like something like continuous integration where it automatically builds up the jar file after any changes?
Absolutely. I mean,
Okay.
not in the Hadoop world, not in the Hadoop world. We will not have that level of things because this all is ad hoc implementation. See, they give the different requirements and we make the changes to the existing code, generate the jar file and keep it. Usually, as I told you even in the last session, MapReduce is being least used in the Hadoop ecosystem. But even if it is being used, we will not be using that level of implementation. Like the moment you make the changes, the build is been automatically triggered and all that level of implementation. Very rare you see. Only when you're working on huge projects where the Hadoop team itself is into hundreds, then only you see that scenario. Otherwise, you'll be working manually like how we are doing it now. Not an issue at all. /work. We are in the data sets. But there's nothing wrong that we set up that kind of environment. The moment you make these changes to the code, it automatically compiles, build, produce jar file and keep it in the predefined location on the HDFS. Then Uzi is going to run the job in the scheduled time. That is definitely possible, but we don't do at that structured level because this all is ad hoc, right? Not something which is very predefined. The job is running now, and as part of this part-r files, we should see the part-r files not yet produced, because part-r files will be produced only. Part-r files will be produced only when your reducers are going to finish the execution. So till then, it is going to be a part of the temporary location, and finally, when your reducers are going to finish, then you will see the part-r files being produced in the same path. 4 part-r files you will be seeing, because we configured it like that. Job.set num reduce tasks. We made it 4. That is the reason why we see 4 part-r files. Each reducer will produce 1 part-r file. Okay, finished. And if you go there now, slash tmp slash sandbox slash Mary underscore out. You notice, dear friends, if you look into this one, the part-r file that is being generated, you see that you try to count the number of key value pairs here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 19. We have 19 here. So within this part-r file, everything is going to be in the sorted order. Within this part-r file. So we have around about 19. And if you go to the next part-r file also, near about 18, 19, somewhere we should see. 2, 4, 6, 8, 10, 12, 14, 16, 17. You noticed here? And even if you go to your next part-r file, you'll be seeing 2, 4, 6, 8, 10, 12. And the last part-r file you see 2, 4, 6, 8, 10. So you look closely into this one. Inside each part-r file we have the sorted. The output that is given from all these mappers, mapper 1, mapper 2, mapper 3 on node 1, again mapper 1, mapper 2, mapper 3 on node 2, the output from all the mappers is actually being routed through the respective reducers through the partitioner and shuffle sort phase before the inputs given to the reducer, they are being sorted and given to the reducer. As we have mentioned, 4 reducers, whatever the output you are getting from across. But interesting here, you see there is only one, I don't know whether you noticed that or not. If you go to the job and see number of mappers worked for this particular is only 1. You notice that? So the output of this mapper only is distributed to 4 reducers. So this implementation is done only to make you to understand that number of reducers can be fixed by you. Only to bring that concept to your notice, this is actually been set. In the same, if I take out that and keep the number of reduced tasks to be 2, then I'll be seeing you'll get only two parter files. You'll get only two parter files. You'll not get four parter files. But it will not make any sense in this implementation particularly, because the text file that we are trying to process, the Mary file, it is a very small file, not even the whole block at the cluster level whose size is 128 MB. So that if you are splitting to multiple reducers, it is of meaningless. But this is only to demonstrate that at times when it is required, you can make the number of reducers as per your choice. Based on the number of reducers, the amount of the output that is produced from the mapper phase is uniformly distributed to all the reducers that are running. Thereby, the, the, the time which it takes to process your entire data is being kept at the control. Mappers, it is purely in the control of the environment. We don't have any choice there. But when it comes to the reducers, if all the output of the mappers is processed by only one reducer, it takes more time. Say for example, we have 150 mappers running in the background processing 5 GB data. You have set the number of reducers to be 1. Then what happens? Mappers may finish the execution fast, but it is being held up with the reducer because the output of all the mappers need to be processed by one reducer, which is going to be a time-consuming process. So by looking into the amount of data that you are processing and the amount of the data that you expect after the mapper phase, you need to decide how many reducers need to work for you in the background. It makes sense, friends?
I have a question here, Srinivas.
Yeah, please.
So can we decide on this number dynamically at runtime? Because our data will be, the data that we supply for the job might be changing at different times, right?
Wonderful. So this can be done by you by passing the command line argument. By passing the command line argument, you can always do that as a property or as a command line argument. See, ultimately what is required? Job.set number of reduced tasks need to be decided, right? See, whatever the number you specify here, those many reduced tasks will be functioning for you in the background. You agree with my point or not?
Yeah.
So here what I do is, whatever I am getting from my, you look at this one, integer dot parseInt of args of, you got the point what I'm saying? What is that? Arg0, okay, that's not a problem. Here they have mentioned it as arg0. We'll take that one only. The method parseInt string is undefined for the type integer.
I think we need to say arg0 of 2 dot parseInt inside that, since the argument is a string.
Argument.
So the parseInt method we need arg0 of 2 dot parseInt. Again, we need to convert that to int, I guess. The command line argument that we're passing is a string object.
1 second. Integer dot so we can directly use string there, that's not a problem. The parseInt method, which takes string, converts that into numeric value. So integer.parseInt of integer.parseInt of, is that clear? If the same code is being, now I say here export jar file and the number of reducers we decide this time, and I click on finish, yes, okay, here. Now what needs to be given? What needs to be given?
Argument, pass the argument.
We need to
The
pass
number
it
of
as a
reducers.
third argument. So we have two arguments already here, Hadoop jar work slash MapRed and everything word count, and then finally we give 2. Look at this. Connecting to the resource manager, processing that one, and this time we need to see the number of reduced stars that need to function for you in the background. If you go and see that, so you'll be seeing how many reduced tasks will be functioning for you in the background. As a result, you need to make sure that you can see the tasks here. Only the map phase is still getting executed. That is the reason you are able to see only that. When the reduce phase also starts, then you should notice how many reduced tasks are functioning for you in the background here. How many reduced tasks are functioning for you in the background here, friends?
2.
2 of them.
Because we passed 2, and obviously we are going to see the outcome from this one. So this is how we can make it dynamic. And you also can go and see the output that is there as part of your /tmp/sandbox, and in that you have Mary_out. You see only 2 parter files. And you notice even here uniformly distributed. You see here within this one everything is sorted. You go and see the second parter file and you have yes. Is that clear?
Yeah.
Makes sense, friends? If you
Yes.
want, you can also send it as a property by using your -d option, and you can read the system properties. Along with that, you can get that property. But this is a straight away implementation what we did here. From the command line, you pass the argument and that we receive inside, because every argument that we receive from the command line is going to be in the string form, and that I am converting into integer and giving it to my set number of reduced tasks. That way we can make it dynamic rather than fixing the value there. Runtime based on the input path you are giving. If the input path is a heavy sized data set or a directory, then I want more reduced tasks to function for you in the background to process the data, then comfortably I can give the number of reduced tasks to be more, which I can decide dynamically when I am about to run my MapReduce job. That is always possible. This makes sense, friends? It is the same word count that we eliminated this logic for the reason this logic is applicable based on the data set you are going to process. If it is an XML file And in that XML file, if there is a tag by name text, then only this logic is applicable. Otherwise, this logic is not applicable. So what you understand from this entire discussion? So before you start processing anything, the first and the foremost thing that we need to do as a developer is to understand very clearly what is the data set. What is the data set? We need to clearly understand this. Based on the data set only, you are going to, one side we need to understand the data set thoroughly. That is what we call it to be data set description. So sometimes this data set description may not be that clear to you, and that time we need to have at least the domain knowledge in understanding the data set. The domain knowledge. Say for example, you are working with a banking domain, assume the files that you come across, or you're working with the telematic data. If you are working with your telematic data, each field has got some importance. Then only we understand, oh, this is a field which represents this type, and I need to use this type like this inside my processing. I need to have all that understanding. That is possible only when you study the data set. Once you have clarity on the data set, then we can get the requirement. Based on the requirement, what we do is we are going to develop the logic. And this logic we need to make sure we fit into map function, we fit into the reduce function. What logic should go from this logic, what should go here and what should come here, you need to decide. Based on that, you are going to implement the job, and that job when you submit to your job tracker, and it is going to pass it to task tracker. Under task tracker, it works as task, and finally you are going to get the outcome what is being. Even your MapReduce job, what is being submitted, to keep this job in your control, you can configure your number of reduced tasks and all, and those can be dynamically passed from the command prompt, what we have observed just before. But coming to the mapper task or map task, this will not be in our control. This depends upon the number of splits. I think you notice why there is only one mapper functioning for you in the background, because of the reason the number of splits for this particular input is, I think you see here, total input passed to process 1 and number of splits 1. That is the reason why we are seeing only one map task functioning for you in the background, right? So that is what you need to understand here, friends. Now look at the same. I'm going to show you one more data set. Look at that here. Work, inside work we have data sets. As part of the data set, you have a file by name. Look at this data set. This is 1901. Same. You also look at this 1902. This is a weather data set basically. Each line is the record sent by the sensor and captured by the weather server and stored as part of the file. So you look closely into this one. You know you have weather sensors, and these weather sensors are going to capture the data, which are with these weather sensors are being set at different locations. All these weather sensors are going to send or emit data in fixed interval of times. In fixed interval, these sensors are going to emit the data, and that is being captured by this weather server and produces a file. Maybe every year we have one file, one data set, and that is what your 1901 is. And we have one more 1902, like this we can have. So the temperatures recorded globally, maybe every 5 minutes, I get the temperature, or I capture the weather data and send it to the server. So in an hour we get 12 into 24 into 365. That is going to be the size of each data set. For every year I'm going to capture the data like that. And finally you are seeing whatever the data that we are seeing here, this is what. Now I ask you, from this file called 1901, I want to find out the maximum temperature recorded. I want to find out the maximum temperature recorded for the year 1901. And same like for the year 1902. If I supply 115 from 1900 to 2015 or 2016, if I supply 116 files, then each year I should get what is the maximum temperature. Thereby, I am able to draw the graph, and with my domain expertise, I am going to predict that the coming 4 years, the weather pattern is going to be like this. That is what your weather scientists are going to do by processing the data so fast. Now I ask you friends, from this 1901, if I need to find out what is the maximum temperature, what inputs you need? What inputs you need?
So you need 1901.
No, definitely 1901. But if you look at this data set, it is like, Greek and Latin to us. We are not able to understand anything. But each line, whatever you are seeing here, represents one record. This record has got the complete details about the entry made by the sensor, which is captured by the weather server. So each line has got the complete details about timestamp will be there, year will be there, of course, part of the timestamp year will be there. Then what is the temperature, what is the air humidity, various details are being captured and being sent. Now what is the immediate step from our end as a developer?
We need to split this record into the values.
No, we need to first understand this data.
We need to encode or parse that data.
Weather
Decode, sorry.
data set description. You need to first understand this weather data set thoroughly. Weather data set thoroughly. You need to first understand this weather data set thoroughly. Why we need to understand this weather data set thoroughly? What each token represents inside this weather data set, we need to know. Then only we will be able to do anything. I think that should be there with me. Data sets description kind of file should be there with me. Let me see that. If not, we find it out from the internet. Data sets description. Yes, data sets description. It should be there. Yes. See here, friends. Yeah. baseball data set we have airline data set we have, and oh, this is not there. Weather data set description, we need to get that. Airline data set description we have. Yes, exactly. See here, this is how you are going to get the description for, and we need not worry for that one, friends. And why, from where we need to get that and all, we need not worry, because this is going to come. They are going to give you the details about what is this W band number, what it indicates, longitude, latitude, daily max, minimum. So all these, whatever you are seeing here, surface temperature, this is humidity, relative humidity, soil moisture. So all these things, each token, whatever you are seeing there represents, they are going to specify. This is a record, and in this record, these are the fields, because this is being generated by the sensor. Sensor data will be like this only. Whatever you are seeing here, the sensor data will be like this only. Now, if you look closely here, I think you are seeing 1901. I think you see here 1901. You notice that here? Friends, are you able to notice this one here?
Yeah.
So if you look closely into this one, each thing represents whatever. First four characters represents this. Next four characters represents this. The next four characters, that is what we are technically calling it as data set description. So before you take up any MapReduce job implementation, you need to first get this data set description, thoroughly study that, understand, then only you can look into the requirement. So this is what my data set is. Imagine that we have understood this data set, and my requirement is from this data set, I need to find, after processing all these records present inside my 1901 file, I need to find out what is the maximum temperature recorded. What is the maximum temperature recorded? So for that sake, what I am doing is I am copying both these files to my Hadoop fs-copy from local 19 not star to /tmp/sandbox. I'm copying these files to my /tmp/sandbox. I have 1901 and 1902 files been copied. Hadoop fs-ls/tmp/sandbox to make sure that the files are being copied from local file system to my HDFS. I think you noticed here. Oh, I don't need a 1901.zz file. I remove that one. Hadoop fs-rm-skip trash /tmp/sandbox slash star.zz. So we have that now. And as part of this one, we also has got a MapReduce job. What is a MapReduce job you have? The MapReduce job we have is max temperature. So let us not worry about the logic inside. We see that logic after running the job. We have the class and we have a mapper, we have a reducer, and we have the driver code. Take any MapReduce job, its structure is going to remain the same. We have a top level class. Inside that we have a mapper class. Inside the same top level class we have a reducer class, and we have a main method. Inside the main method we write the driver logic. Driver code, mapper class, reducer class, all packed into one job. That is the reason why we are calling this as a MapReduce job, and all the other things are inner to this job. That is where your mapper is a static inner class, reducer is a static inner class, and your driver code is kept inside the main method, because that is the entry point for the execution of your respective job. So what I am trying to do now is Hadoop jar I specify /mapred/mrjobs.jar, and I specify here max temp is the name of the job, which you can see here in this one. What is that? Max temp. What is the job associated with that? com.sa.mapred.maxtemperature.class. That is the reason why I am giving that one here. Max temp /tmp/sandbox. So I want you to learn one more thing. Instead of we giving the file names like that, I also can give the glob. I already mentioned it to you before. Matching with this pattern, all the data sets are being processed. Now you need to see the output coming in such a way, total input paths to process 2. Total input paths to process 2, not like what we got before, total input paths to process 1. So /tmp/sandbox/max_temp_out, and I run this one. Let us see what is going to happen. What is that? Total input paths to process, what it is telling? It is not telling 1, it is telling total input paths to
2.
process 2. And number of splits, 2.
2.
And you see the number of you go and see here, number of map tasks that are going to run for you in the background. That also, if you see closely, you will be seeing, you will be noticing. Earlier we have only one map task that was functioning, but now if you go here and see, how many map tasks are running for you, friends?
2.
Did we specify anywhere that the number of map tasks should be 2?
No.
That is what you need to understand. But by default, your number of reduced task is taken to be this one. And now my intention is to go to the output and see. Output is my criteria here. So /tmp/sandbox, and in that we have max_temp_out, and you have your part R file. It is going to show for 1901 year 317 degrees Fahrenheit, and 1902 it is 244. Like this, if I provide 1903, 1904 and all those if I provide, then what is going to happen? Each year I am
So
going to
it will
get,
take number of, sorry.
you are getting my point?
Yeah. So it will take based on number of years. So it will take number of process.
No, not number of process, because we are providing separate files, right? That is the reason why you got for each file that we have given 1901, 1902, you have the map task functioning for you in the background. If the entire data is present inside one file, and based on the number of blocks or splits present, the number of map tasks will come into picture. So map tasks will be decided based on the number of files, number of splits, and the availability of the resources. We cannot confirm that total input paths to process 2 here. That is why 2 map tasks need to function. If resource constraint is there, then maybe only 1 map task is going to function for you. The same JVM is going to be reused to process the next set of data. So this kind of output if you get, I can definitely draw a graph that one side I take the year, probably I take the year, one side of the graph I take the year. So how I take the year? Like this, I take maybe year I take here, and here I take temperature, and maybe here it is 1901, the temperature is here, 1902 the temperature went up and maybe came down, maybe it went up, it came down, went up. Now observing this pattern and the global climatic changes happening, various warming, global warming and all happening, and various other elements influencing this one. Observing all these things as a weather scientist, not you and me, with their domain knowledge and the other elements to take into consideration, they can predict that the next 4 years, 5 years, what could be the maximum temperatures globally. They can decide that, not you or me. That is where I say, as a Hadooper, we are going to understand the data set, we are going to understand the requirement thoroughly, matching with the requirement, we implement the job, process the data and make it available, so that that data is going to be consumed by the analyst to further analyze the data and get the meaningful insights of the data that is being produced by you as a result of processing it. Make sense, friends? What I will do is I am going to share the data sets that I am showing you here. I'm going to share this data set and its description also, this data set and the description, and the jobs that we are developing here. This is the max temperature job which I am developing here. So how I am getting that one? The entire record I am getting as a string. From that string between 15 and 19 if I take, I am going to get the year. If the character at 87 is plus, then between 88 and 92 I get the air temperature. If not, between 87 and 92 I get the air temperature. So how I come to know this one? How I come to know that exactly go to this location and read that one, then you'll have air temperature. How I come to know? That is only from data set.
Understanding the data
Data
description.
description.
Understanding the data description.
Yes. That is the reason why I am saying to you, before you take up any MapReduce job implementation, we need to make sure that the data set is being thoroughly understood and you are very clear about each element or entity of the data set. And the other side, we try to understand the requirement in detail. Mapping these two things, we are going to write the logic, and that logic we decide where to keep inside the job what part needs to go and sit inside map task and reduce task, and finally to get the expected outcome. Hope this makes more sense, friends, than what we did in the last couple of sessions. We are now trying to go deeper into the implementation part and trying to understand more aspects. And in order to work with this one, you don't need the MapReduce API, exhaustive MapReduce API, same thing. Even if I go to a different MapReduce job, randomly I'm taking, you have a class, you have a mapper inside, you have a reducer inside, and you have the driver code. That's it. Take any MapReduce job. That is why I'm asking you, friends, please go through the MapReduce API thoroughly. Then only you'll be able to use it effectively as part of your implementation. Whatever the MapReduce job you develop, its skeleton or structure is going to remain same. It will not be different. Make sense, friends?
Yep.
So please go through whatever we have discussed it in the today's session. I think this word count also, how we have changed the code based on the data set and made it to function. You might have noticed the troubles that are being encountered during the execution, how they are being handled. So don't expect that the moment you develop a job, you convert into a ZAR file and you submit, it should work absolutely fine. If it works absolutely fine, we never can learn how abnormal things can be handled by you to make your implementations work as per your expectation. So let you encounter troubles. Don't get panic. The more you encounter troubles during your practice, the more robust you become and you'll be more productive at the workplace. So make sure that you go through the video once again and try to run the MapReduce jobs, whatever we discussed. So based on that, we see how we drive it further. I'm going to upload all the data sets and the related Java files. So please make sure that we are going to create a project and add all these things to your project, generate a ZAR file. You want, please go through the video once again, stop somewhere and do the same thing what I did and continue. That is how you can make your implementation to happen. Even then you have any question, never mind, we discuss that in the next session. That makes sense, friends?